Hi, welcome to Parametric House. In this Grasshopper tutorial, I want to show you how you can convert a series of polylines into a parametric cabinet. What you can see here is that if I give a new polyline to the input, it's going to be updated. We can also give multiple polylines, so I can also add a polyline here, a polyline there, and right click and set multiple polylines. And it's going to update. The first input is the base width, so this is going to be the width of the cabinet, which we can change here. Another thing is the top width, so we have a little bit of an extension at the top, so you can also change that here. If it's 0, it's going to be the same as the width, and if you want to, you can increase that to give it even more offset. There is a division length, which is going to be the main division of the cabinets here. So if I change that, you can see that I can increase the number of divisions here. Let's zoom in. This is going to be the division. There's also a length for the corners. So if I just go to the corners, if it's near the 0, it's going to be just a complete corner here. But if I increase that, let's just increase that to even a higher number. This can be the length for this two parts at the corners. So we can also control that length too. And it's going to be used for all of the corners. As you can see here, I can change that length. There is also a top thickness just for visualization. We can change the thickness of the top, and a base height, which is the height of the cabinet, which we can control. And at the end, we can have the top as a solid, as you can see here. You can also extract the curve, which I'm going to explain, and also the base, which is going to be these parts. As you can see here, this is going to be the baked final result in Rhino. If you open the zip file, there is an example file, which is going to be the algorithm, and also 7 ideas. For example, if I open idea 4, you can see that we have given this polyline to the inputs, and also to give you an idea of how you can use this component. For example, idea 6, you can see that you can make like multiple arcs like this for the division, and also idea 7, so you can see that you can use that for a curve. For any curve you want, a polyline, and use it in your project. So actually this algorithm helps you to produce parametric cabinets just for visualization, and for a starting point I think it's not bad. It's going to help you to generate it really fast by defining corners, and also the length at the corners, and also the length at the start, which you can always control. There's also an example file, which is the complete algorithm, and I'm going to explain it here, how it works and how we have used it to produce the final results. Okay, let me just turn off everything, and let's talk about the first part of the algorithm. So here we have the polyline, for example. This is just, let me bake that, the two parts of this polyline and a simple line. What we have done here is made a pipe to get the base, which is going to be a B-rep plane intersection. I can also extract the plane here and turn it off, so you can see it here. We can also use the curve offset tool, but you have to offset it twice, so it's just like plus and minus. But because we are using a few polylines, we can use this pipe B-rep plane technique to just find both of those curves faster. Also, if you click on the pipe end and make it a flat, you can use this technique to have a closed area for the curve. So this technique is also useful. Remember that we can use the pipe B-rep plane or double offset to make the final result. Okay, now that we have this, we're going to loft it together to make the boundary. For the loft option, I have used the surface freeform loft option here, and use this adjust seam to true, so it just makes a complete good loft from any polyline. After that, I have used the surface utility merge faces to merge the faces. So if you bake the loft here, you can see that this is going to give you a series of edges at the corners, but if I merge the faces like this, those edges are going to go, because this is really important as we go forward to solve the problem. Okay, this is the first step of making the surface. Now what we want to do is to define a division. So I'm going to divide these lines here, make a line. We're going to split it. We're also going to analyze the start and the end of the corner. So for example, if this is the length, we will have an additional length at the corners, maybe L2, which we can control. Okay, let me explain the logic here. So assume that we have a multiple polyline here. What we have to do is to first extract the start and the end. The problem is that we are defining corner cabinets. That's why it's making it complicated. Okay, so for the start, we're going to start dividing it based on our desired length, and also we have to define a corner length here. Okay, so because the line is in this direction, we're going to start from the start, and at the end we're also going to give a additional length we want, so it's L2 for example. At the end, because the polyline is moving like this time we're going to use this L2 at the start and then divide it into whatever we want. So remember, because of the two different directions, we have to extract the start and the end. Another thing we have to do is to find the leftovers, which is going to be these three parts, and then we can say that get an L2 from the start and the end, and then divide the rest into the division we want. Okay, so that is exactly going to be what we're going to do with the multiple polyline.